Welcome back. Here's part two. We're going to do secant, cosecant, and cotangent. But I really think you just need to do them in the first quadrant and then just think of them flipping to all the others. Because just the same way that the sine, the cosine, and the tangent flip around to all the others and just change signs, we're going to have the same thing going on with secant, cosecant, and cotangent. Okay, so this is going to get a little busy right here, but let's do cosecant of pi over 6. Well, the cosecants are reciprocal of the sine. So take the sine right here and flip it over. Boy, that was hard. So anytime you ever get cosecant of pi over 6, it's going to be either 2 or negative 2. And all you got to do is figure out which one it is. So you want to know what quadrant you stop in. Because think about this, sine is negative. All the signs are negative in these two quadrants down here. So if you get a cosecant of some pi over 6 and it's in one of these two quadrants, you know it's negative. Because we're below the x-axis. If it's up in these two quadrants, you know it's positive. So there you go. That's all there is to it. Look, that's a half 2. Flip it and you get 2. You can actually just flip these in your mind. What's 1/2 flipped? Oh, I don't know. Maybe it's 2. Okay, let's go up to this one. Cosecant of pi over 4. Oh boy. Now in this one, I've got to take root 2 over 2, and I've got to flip it. That's going to be the cosecant. But of course, we're not allowed to leave. Oh, that's it. That one seems easy. That one's just root 2. So right here, cosecant root 2. And then for this one up here, the cosecant of pi over 3, I need to flip this one. It's going to look like that. I get 2 root 3 over 3. This one is 2 root 3 over 3. Now we'll talk about flipping the ones on the axes in a minute, but guess what? Those 3 numbers are the only 3 numbers that exist for cosecant, and they're the only 3 numbers that exist for secant also. But just keep in mind that we're in a change place mode right here, because if I flip this one over, I'm going to get 2 root 3 over 3. If I flip that one over, I'm going to get root 2. If I flip this one over, I'm going to get 2. It's the same 3 numbers. So on the pi over 4s, they're alike. But these others just trade places. The 2 and the 2 root 3 just trade places up here between secant and cosecant. And now I'm just down to the cotangents. So let's get the cotangents on here, and then we'll be able to look at some problems. Okay, so cotangent of 30 is just the same as the tangent of 60 up here. That one's going to be root 3. On this one, the cotangent is also 1. And on this one up here, the cotangent of pi over 3 is root 3 over 3. Cotangents are the same 3 numbers as tangents. 2 of them just switch places. Okay, So please think about this. Tangent and cotangent has got to be one of these five. Okay? Secant and cosecant can either be this one, or that one. And then, of course, if you flip 1 over, you get 1. If you flip 0 over, you get undefined. So it's just those 5. It can only be these 5 for secant and cosecant. It can only be one of those 5 for tangent and cotangent. So you got a 1 out of a 5 guess, except you know these two are on the axes and the others are not. And so my suggestion is learn this first quadrant. And then you should be able to do any kind of problem. Okay? So let's do some out of this book, and then we'll give you your homework, which is different problems. Let's see, sines and cosines we can just read. Oh, there's cosecant of 7 pi over 3. So think about this. 7 pi over 3, So find pi over 3. It's right there. And we wanted, what did we want? Cosecant? Cosecant of the pi over 3. So the answer is either 2 root 3 over 3 or it's negative 2 root 3 over 3. So you have to ask yourself, where would 7 pi over 3 stop? Well, 6 pi over 3 is the same as 2 pi. That's one around. So this stops in the first quadrant. 2 root 3 over 3. Just write it. Cotangent of 7 pi over 3. Okay, so let's look at pi over 3. There's a cotangent, root 3 over 3, and we know it stops right here. 6 pi over 3 is the same as 2 pi. One more. Cotangent, root 3 over 3. This one would be, where was that? Root 3 over 3. That was not too bad. And the same thing on all of these others. Okay, look at that one right there. Secant of 11 pi over 3. Well, just go pull your reference angle. Look pi over 3 up. We want the secant of it. Here's pi over 3. The secant is 2. Okay, so this is either 2, it's either 2 or it's negative 2. So the whole question is, where in the world would 11 pi over 3 stop? Which quadrant would it stop in? Well, if that was 12 instead of 11, 3 would go into 12 exactly 4 times, and I would stop on the x-axis. This stops in the 4th quadrant. All secants in the 4th quadrant are, look at them. They're the cosines flipped. They're the cosines flipped. I'm right here. I'm this one. The answer is 2, not negative 2. Just figure out where you stop. I may attach an article on this, or not. And then here's all the 7 pi over 6s. So these aren't too bad. These are expected to be read. We want you to read these off your unit circle. Calculator will do you no good. If you give me a whole list of decimals, I usually count all those wrong because we want you reading this off your unit circle. So look right here, find the exact value of each trig function. We want you to do 7 through 10. So do 7 through 10. And then do this bunch down here, 24 through 31. 7 through 10, 24 to 31. And that should be good. And we will return.